So hi everyone, I am Zelal Aldağ and head of data science team in Sensgreen. It's based in Ankara and we are using energy and indoor air quality monitoring. So okay. As we know that more countries, cities, businesses and other institutions are committing to net zero emissions. And we have targets expected specifically from buildings in order to achieve that net zero goal. At first, the Paris Agreement targets will require buildings across the globe to improve energy intensity by 30-50 per square meter. And moreover, existing buildings account for approximately 34% of global final energy use and approximately 19% of global greenhouse gas emissions that are energy related. About the existing stock problem, I want to mention an example. Commercial buildings constructed before 1980 take up 54% and before 1989 take up 71% of all commercial buildings in UK, which means there are a lot of old buildings taking up a huge percentage of existing buildings. And according to IPCC report, over the whole building stock, the largest portion of carbon savings by 2013 is in retrofitting existing buildings and replacing energy-using equipment. Also, energy savings of 50 to 75% can be achieved in commercial buildings that will make smart use of energy use. And let me quickly mention the COVID-19 impact on buildings and occupants. So occupants became much more sensitive to the environment they live after COVID-19, and building designs are improved for social distancing, and occupants are expecting transparency regarding to their health level of the building also. And buildings are used more dynamically, such as hybrid work environments and rise of co-working spaces. And finally, there are some engineering services started to become more important than ever. As Adrian mentioned, there are mixed mode natural ventilation solutions, and also reduce of reliance of touch is really important as well. Okay. Let's talk about startups in the big picture. And there are a number of buildings waiting to be renovated. However, most of those buildings do not have enough resources to renovate the building, implement infrastructural changes, and detailed retrofits, which are costly and difficult. In addition to that, developing complex engineering solutions can be difficult to obtain due to lack of talent for quality engineering services for individual buildings. So that we can raise the question, how can we democratize energy efficiency solutions for those buildings? At this point, we can introduce startups, corporates, and policymakers. Startups are the first chain of this pipeline, and they can provide quick, specific solutions for buildings. The life cycle of the life cycle of product development and adoption of latest technologies are faster in startups, and they can provide specific on-point solution for unique issues that can be seen in many different industries. Also, in the market, startups can respond and adapt to problems of customers more rapidly than bigger corporations. In the second place, there are corporates. They are also valuable in this chain since they have money supply to invest in startups and new technologies, and they are the potential bridge between startups and policymakers. Corporates are also important because they can be both customers and facilitators for the energy sector. And finally, the most important part of this chain is policymakers for us. From a startup perspective, we can observe the obvious positive impact of mandatory regulations for energy efficiency. Even though most companies have a passion for energy efficiency targets, corporates in countries that have mandatory regulation tend to invest more in smart grid solutions, as we have observed in the market. Okay, let's talk about the solution, about the building stock problems and retrofitting problems. So, buildings are already connected to technology. However, we should not consider it as a one-way communication flow. Instead, the technologies and occupants should interact with each other interoperably. With the intelligent layer between the controllers and sensors, we can achieve smart buildings so that without any interaction to the building management system, energy consumption can be optimized, as well as the comfort of the occupants is kept at the maximum. So let's start with the first technology. It's IoT, LoRaWAN IoT. And LoRaWAN implies long-range wide area network. Unlike wireless technology, LoRaWAN covers larger areas such as 10 to 15 floors of a building as a long-range coverage. And as a long-range coverage, good building penetration, low path loss. Also, it demands significantly low power to operate. In addition to that, for smart grid buildings and smart cities, it's an ideal technology since they can transmit smaller size sensor data with minimum energy. There is another important feature of LoRaWAN IoT network units, such as sensors, is that they can do bidirectional communication, which means they can both transmit and receive data. This also enables smart wireless remote controllers, which I will mention later in this slide. Overall, we can obtain lower cost of implementation, higher coverage, less energy consumption, and customizability with LoRaWAN IoT technologies. And customizability can be obtained with bidirectional communication, which you can set and get data from it, send and get data from it. And it also enables countless use cases in buildings like air quality, cold storage, HVAC equipment performance, and energy monitoring. The second technology I would like to mention is artificial intelligence. Although building automation and energy management systems have been available for some time, they mainly focus on monitoring and providing alarm capabilities. By using the AI layer, we can also use smarter systems that already existing static technologies could not provide in those old buildings. And it's the key concept behind self-operated, sustainable, and healthy buildings. With the increasing convergence of smart buildings, there is great value in developing a central analytics platform to provide more insights from the combined data. The most crucial element in the success of AI is in the collection of accurate and granular data in real time, so that LoRaWAN and AI can contribute to each other for increasing success. Overall, in smart buildings, AI can collect and monitor information, control, evaluate, and manage energy consumption in the buildings. Also, it controls energy usage and reduces it during the peak hours, such as in load hours, identifies and signals problems, and detect equipment failures before they occur. To be specific in load hours, it can be explained as pattern detection of the load hours. And final technology that I want to mention is smart remote controllers. As the final part of this chain, they are the edge of this system, and we want to achieve both load flexibility and energy efficiency in controller systems. It's a key technology behind the democratization of energy efficiency in buildings, as I mentioned before, because they are LoRaWAN mostly in our cases, and it's easy to install. And only 3% of buildings in United States have BMS to control units. All the cabling and installation works make BMS inexpensive to use in old buildings, but with remote controllers we can eliminate this expense. And wireless control devices are becoming more popular in recent years. Without needing any BMS or cabling, you can connect these devices directly to HVAC units, and they give an opportunity to apply AI decisions on HVAC units. And finally, we can apply the results of cloud computing decisions on the edge. Okay, let me finish with 2 examples. Our first case study is a healthy office example. After COVID-19, people wanted to go back their office safely, and also the facility managers had to achieve energy saving, meanwhile keeping the indoor air quality level high. So as a solution, we implemented 30 indoor air quality sensors and 6 power meters deployed for real-time monitoring just in an hour, because you just put the sensor and scan the QR code, and it's just connected to our monitoring environment. Also, air quality is transparently shared with occupants in real time, and feedbacks are collected related to their comfort levels. Facility managers started to get analysis and alarms to optimize the HVAC system and building operation to save their energy as well as maximizing the comfort. Also, finally, they get overall analysis of their buildings with cross-matched analysis of different parameters such as temperature, humidity, particle matter, CO2, and etc. And a lot of real-time insights that are generated by AI-based Sensgreen building analytics tool via our reporting UI. And finally, we got the results of hundreds of feedbacks are collected every month, and thermal comfort levels are optimized. And most importantly, 12% energy saving through HVAC management optimization recommendations, which implies that insights are also really important for facility managers as well. The second case study that I want to explain is energy efficient university campus. So to prevent energy loss through bad HVAC management at the largest university campus in Turkey, we worked with them, and since buildings are more than 30 years old, cabling was not possible, and there were no control system and not enough workforce for the facility management. The buildings were old and bulky, so it was a hard example. But as a solution, we put one outdoor LoRaWAN gateway was installed to cover all the campus, which, as I mentioned, it's the largest university campus in Turkey. And with one gateway, we covered all the campus. Air quality sensors and power meters were deployed to the pilot building. Also, smart valves are installed on the radiators throughout the building. And air quality and energy consumption patterns were analyzed similarly by AI-based Sensgreen analytics tool with our reports. Also, outdoor weather data and projections were collected via third-party API to get more accurate results as well, and give better explanations to users as well. As a result, temperature management was optimized, and indoor air quality problems were determined, and automated reports were prepared for the university management. And finally, 26% energy saving through the smart radiator control is obtained, which concludes the importance of the smart remote controllers in this chain. Okay, thank you